So this is 5.2, College Algebra, and we're going to do systems of equations in three variables. We've done systems of equations for years, and in fact the last lesson was when we had just an x and a y, or just a y and a z or something. And today we're going to do x, y's, and z, three variables, which means you have to have, in order to solve three variables, you have to have three equations. Just like in two variables, you have to have two equations, and when you only have one variable, you have one equation. So what we're trying to do is solve one variable at a time. So we start with three equations, and we cut it down to two equations and two variables, and then we cut that down to one equation and one variable. And then so we find the one equation and one variable, we find the one answer for one of the variables, and then we back substitute. So anyway, I'll show you how to do all that. Alright, and again, what I'm going to do here is I'm just looking at the exercise set. This is number 4. Rather than do it like I normally do and go through the different examples in the textbook, because I don't like the way that they're teaching it here. I think it's too confusing. So I'm going to show you a way to do it that's a little bit orderly, systematic, and hopefully that'll help. So what I normally do is I take the first equation and I relate it to the second equation, and then I relate it to the third one. Okay, so what I'm going to do here is I'm going to write the first equation with just the second equation. I'm going to do it just right here below, and I'll do it in red. So I'm going to write the first equation, and then I'm going to write the second equation, and I'm going to ignore the third equation right now. Okay, and then what I'm going to do is I'm going to write the first equation, and I'm going to ignore the second one, and I'm going to write the third one. Okay, and this works on each of the problems that you're going to be doing. So you don't have to think like, okay, so when does this work and when does it doesn't, or when does it not. So first equation, second, first equation, third. Alright, what I'm going to do is I'm going to look at this set and I'm going to find a variable to get rid of. Okay, it doesn't matter which one you get rid of, just need to find one of them. Alright, I think I'll get rid of the y's here, because this is a positive y and this is a negative y, so I just add these together. I don't have to worry about making them opposite in sign and the same number in front of them, they're already there. Z is the same thing, so it doesn't really matter which one you get rid of. In fact, in this one's a particularly easy one, because look what happens when I add these. This disappears and this disappears, which gives me 3x equals 3. So that gives me x equals 1. Okay, so that's a happy time. Now let's look if I do this one. I'm going to have to change this whole thing. I'm going to have to multiply the whole thing by -1 so that positive x and negative x will cancel. So let's multiply the whole thing by -1. And I'm going to rewrite the first equation again. So I didn't do anything to it, but the second equation will be -x plus 2y minus 3z equals -6. Now I can add these. Those go away. 3y minus 2z equals 0. So notice what I have here. I have a 3y minus 2z equals 0. So what the heck do I do with that? Well, I have to go back to my original equation and try to get one of those equations to just have two variables. Well, what do I know? I know that x is 1, so if I put 1 into any of these equations, my x is going to be there, and I'm going to have a y, and I'm going to have a z. But instead of an x, I'm going to have a 1. So let's just take the first equation and put 1 in there. So y plus z equals 5. Alright, so notice what I have here. I have an equation there, y plus z equals 5, and I have an equation here, 3y minus 2z equals 0. What I have is I have two equations with two variables, so I got rid of one of my variables. And at this point, I can actually take my two equations, put them together, and solve using my systems of equations. Now, there are three variables here. I found one of them right away, easy to find, and I found one of them was 1. Alright, now I have to find my y and my z by putting these two together. And I was like, so let me go ahead and write y plus z equals 5, the one from up here, and I'm going to take this one and put it underneath. Alright, let's get rid of everything else. Whoops, didn't I get rid of that, did I? Alright, so this is all I have to work with now. I got rid of three equations with three variables and have two equations with two variables, so I'm going to multiply this one by 2. So I get 2y plus 2, z, I put a little line there so you know it's a z, equals 10. And then I have 3y minus 2z equals 0. Those go away. And I end up with 5y equals 10, so y equals 2. So I have x equals 1 and y equals 2. Now I just have to find my z. So I'm just going to take, doesn't matter which equation, in fact let's take this one right there. 3y minus 2z equals 0. What is y? I found out y is 2. Since I only have one equation, it makes it real easy to find my z value. So z equals 3. So my answer is 1, 2, 3. So this is my x, this is my y, this is my z, and it's written just like that. 1, 2, 3. Alright, so that one was not as simple. I figured because it was at the beginning it might be easier. I probably should have done it first to find out that it was a little goofy compared to the ones that I want to show you here in a minute. So let's go ahead and do another one. Alright, I'm going to do number 5, although that is one of your homework assignments. So here's equation 1, 2, and 3. So what we're going to do is we're going to just write, we're going to solve for equation 1 and 2, and then we're going to solve for equation 1 and 3. So let's go ahead and just write 1 and 2 down. And we can eliminate any of the letters we want to. So we usually pick the best one. Now this, it looks like it'd be easier to get rid of z's because they're already in that format. So let's just go ahead and add these. Okay, once I'm down to two variables, then I stop. Now I look at my first equation and my third one. Okay, so in red there is my first equation and my third one. And what did I get rid of over here? I got rid of a z. That means I have to get rid of a z over here, even if another letter is easier to get rid of. Whatever I get rid of in this first equation system, I have to get rid of the same thing here. Alright, so what do? I've got a 2z here and a negative z, so if I multiply the top by 2, alright, my equation then becomes, and then my other one remains the same. Then I add, those go away, and I get 5x plus 6y equals 13. Now what I have here is an x and a y here and an x and a y here. The z's disappeared here, z's disappeared here. So now I can bring these two together. So I'm just going to write those in the middle. And then my 5x plus 6y equals 13. Alright, so you've done these before. So I need to decide whether I'm going to get rid of my x's or my y's. Well, if I get rid of my x's, I have to multiply this by 5 to make this a 15, and this by 3 to make this a 15, and that's too much work. Whereas this 2, I can make it into a 6, so I don't change anything here, but I multiply the whole thing up here by 3. So my top number, equation, becomes this, okay, and my bottom stays the same. Those go away, and I get 14x equals 28, so y equals 1/2. Alright, so I found one of my variables, 1/2. Now what I do is I go back to one of the equations that I just did that just has two variables, doesn't matter which one, and I plug 1/2 in, and I find my x. So for example, in blue, if I took my first equation, 3x minus 2 times, I found out y is 1/2. So 3x minus 1 equals 5, 3x equals 6, x equals 2. So I just found a second variable. Now I take both of these answers and go back to the original problem where I have a z, and I put a 1/2 in here and a 2. So 2 plus 1/2 times 2 is 1. So 2 plus 1 is 3, minus z is 5. And then I solve for my z value here, and I get -2. So then my answer looks like this. X is 2, y is 1/2, z is -2, and I'm done. Okay? So that's what I'm looking for. Alright, so I'm going to do one more in the next video that's a little bit trickier, like number 12, and then we'll do some story problems.